Hello, my name is Jasper van Riet, and I'm here to present an industrial case study on mobile web performance titled From 6.2 to 0.15 seconds, done in collaboration with Flavia Paganelli from 30 MHz and Ivano Malavolta from the Vrije Universiteit Amsterdam. The BBC found in 2016 that for each additional second their web page took to load, 10% of users were lost. Furthermore, Mozilla found that a reduction of 2.2 seconds of their web page to download the Firefox browser gained them an additional 60 million downloads over the course of a year. So why don't all web pages load fast? Because it's really hard. There's two key problems. First, finding performance issues and fixing them. Second, measuring if the improvement actually works. This is an industrial case study where a performance engineering plan is designed, a benchmarking tool is created and open sourced, and interventions are implemented iteratively. This is not commonly seen in the literature, where generally one intervention is applied across many different web apps, as opposed to one web app getting a number of interventions. The work here was done at 30 MHz, an agricultural web technology company based in Amsterdam. 30 MHz provides growers in greenhouses a dashboard. This dashboard contains a number of widgets which allows them to get insight into their greenhouse. An example of these widgets is the line chart widget, which allows them to see the progression of the values of their sensors over time. The study was designed with the following research question in mind, which is: what are the activities, improvements, and technical challenges faced in practice when engineering the performance of a mobile web app? The study used the benchmarking tool that it created, which measures 11 different performance metrics. These are common in various categories, which are rendering, computation, network, and general. An example of these metrics is the first contentful paint, which is part of the rendering metrics. The first contentful paint measures the first time content is drawn into the DOM, which in the case of this timeline we see here would be the second screenshot. Another example is the speed index, which calculates an integral over the loading progress of a web page. In the case of the two timelines we see here, the bottom timeline would be unoptimized because it only loads the content at 1.5 seconds, whereas the top timeline would be seen as optimized. Finally, we composed a custom metric called the time to widget, specifically for the 30 MHz platform, which is the time till any widget is rendered in the dashboard. The performance engineering plan was designed after careful analysis of the platform. Some of the conclusions are as following. First, there's a large amount of network calls performed as part of a web page load, almost 250 for a single load. Second, chart widgets are particularly performance intensive and take a lot of computing power to both render and calculate. And finally, the large amount of network calls also contain a lot of dependencies between each other, causing a lot of blocking. The end results are significant. First, the first contentful paint seen earlier was improved by 97% to just around 150 milliseconds. Second, general metrics, which we see as metrics that attempt to measure the overall speed of the web page, such as the speed index and our own lowest time to widget, were improved by around 20%. An example of the interventions we have done is intervention 1. Intervention 1 is about the notification line that can be drawn into a line chart. What this means is that a grower can set a notification line, and when the values in the chart reach that line, this triggers an SMS or an email. The line being drawn into the chart requires adjusting the y-axis. This was a particularly heavy calculation, but was done even if there was no notification line in the chart at all. We were able to make this calculation conditional, which means that we should expect to see a reduction in the computational metrics. And indeed, we do. The total blocking time and the time to interactive were both reduced, and we even see a general metric such as the speed index improved by around 6%. Another intervention we would like to highlight is one of our most successful interventions, which is intervention 7. The widgets come in a long, endlessly scrolling list. What this means is that when we scroll down, more widgets are loaded. However, by default, the dashboards would load 20 widgets. This was often not needed. On a standard 1080p screen, we can only see 6 chart widgets at a time. Thus, we were able to compose an algorithm that would conditionally attempt to render as little widgets as possible. As a result, we see very large improvements across almost all metrics. An example would be the time to interactive, a computational metric which was improved by just over 25%. We see the speed index improved by 17%, and we see a rendering metric called the first meaningful paint improved by just over 21%. For more on the interventions, please see our paper. In terms of the lessons learned, we learned that design decisions must be made with the overall web app in mind and with an openness towards trade-offs. It's almost impossible to please all metrics for every intervention. So web apps should set their priorities and find the metrics that they really find important. Then optimize towards those. Furthermore, the gains made as part of the study were not achieved in a single intervention. Instead, they were achieved over the course of 13 interventions. Thus, there is a continuous need for focus on performance. Third, it's important to utilize a stable benchmarking tool, which allows you to carefully compare interventions and versions of the platform. It's especially important that this is combined with a way to validate the impact of results statistically, so that outliers don't have too much effect. We would also like to extend the work we've done here, particularly to desktop devices, so that we compare mobile versus desktop devices and thereby deepen our statistical analysis. Furthermore, we question whether our metrics here actually represent the user perceived performance gains, and thus we would like to perform a user study on the metrics. Thank you.